Hi guys, I'm Darren and today we'll be installing the Yaapu Horus mapping widget on our color LCD OpenTX transmitters. Okay, so before we start, what is the Yaapu Horus mapping widget? Well, it's a LUA script that sits on your OpenTX transmitter. It will work on any color LCD, so TX16S, T16, T18, and of course the Horus transmitters. And what it does is it uses the telemetry that you get back from your flight controller with your GPS coordinates on to show where you're flying on the map. I believe it shows heading and all this sort of stuff as well. And you can also set up some telemetry sensors along the outside edge. So we'll go over that later in this video. And you can have free zoom levels, so we can have varying levels of detail on the map itself. So where do we get started? You can see on the screen the GitHub repository for the Yaapu Horus mapping widget. So this is the address. I will put it in the video description, of course. And all we need to do is download the actual files themselves. So the easiest way is just to do download zip. So there we go, we'll stick it on the desktop. Now while we're here, what I will do is we actually need another tool to do this. So if we head into the wiki, which is pretty decent instructions on how to do all this anyway, but there will be a link in here for installation and configuration. So this tells you how you need to set up your OpenTX. You need to have LUA scripts. LUA C is always automatically included now. I believe that was 2.3.9 or 2. Yeah, I think 2.3.9. There was no longer a checkbox for LUA C. It's just automatically installed now. So that's how you get it on your OpenTX. Just make sure that you've got LUA scripts on your firmware, which I'm sure most of us have anyway. But the more important thing on this is the mapping widget itself. So there's two parts. There's the part that goes on the transmitter, which is displaying, but we also need to get the maps to put on the transmitter. So here is this GMapCatcher, which if I open in a new tab, click on there, and then you can see the executable file here. Now, as far as I know, this only works on Windows at the moment. I don't know if there's any plans to put it on other platforms. As you can see, this is still a pre-release, but we do need this tool. So if you haven't got Windows at the moment, I think the only way you can really try it is with a virtual machine or something like that to try and get the maps downloaded. So again, I'm just going to save that on the desktop for the minute. So what have we got? We've basically got this zip file here with our transmitter stuff in it, but I'm not going to touch that for the minute. At the moment, I'm going to go through the actual mapping capture tool. So at the moment, we just need to install it. If you get a Windows message pop up, you can just choose run anyway. It's an absolutely fine tool. And once you've installed it, you'll get obviously this icon on your desktop, and we'll also get the tool itself. So what I'm going to do is just show you how to download the maps. So the first thing I'd recommend doing is putting on satellite. You can use any type of map that you want. So there's a standard, like for some reason it always thinks it's offline. So we'll go back to online. So there's this sort of standard illustration map. There's a satellite map, which actually has you can see where hills and forests and all that sort of stuff is. So if we zoom in, you can actually see there's a fair bit of detail here. So we have paths, trees, hillsides, all that sort of stuff you can make out with this tool. So I'm going to zoom back out to about level 6. And the final one is terrain, which again is like a cartoon drawy one. But to be honest, I was expecting more actual terrain lines on it. But it just seems like it's different colored for different terrain. So you get that information pretty well from the satellite anyway. So what you need to do is download an area. So what you would tend to do is find the area that you want to download. So depending on how big an area, zoom into the biggest area you want to download. This isn't the scale that you want to see it at. This is just the actual area that you wish to download. You can preview the scale to see it at, obviously, using this tool here. So let's find an area. All right, so this is just a nice sort of rural area. And what you'll be looking at here is the number on this side of the screen. This is the map zoom level. So what you would do is scroll down until you get to like a scale that you'd like to see. So you can see this, it actually has down here, but that distance there is actually almost a kilometer. So 0.9 kilometers for that distance down the bottom here. So judging by that, so it's probably, I don't know, about 9 kilometers across maybe. We can actually find out easily. We just go on the download thing. So yeah, 8.3 kilometers up across and 4.5 kilometers up and down. So that's on map zoom level 3. So when I've been downloading stuff, I've actually been using map zoom level 3 as my furthest out, because you're going to, there's quite a bit of distance there, so you be able to get a good judge of where your model is. Of course, we're only flying line of sight, so you'll never worry about that anyway. But then what you'd obviously do is then find your closer zoom levels that you want. So with Yaapu as it ships right now, the zoom levels need to be next to each other. So if your maximum out is 3, you need to download 3, 2, and 1. Likewise, if you want your minimum zoom level to be sort of -1, you'd be -1, 0, and 1. There's just this linear zoom at the moment. I have actually put a pull request in on Yaapu, which will allow us to actually just choose 3 zoom levels arbitrary. So we can have a level 3, then we could have level 1, and then we could have level -1, for example, which is a really zoomed in, which is not actually downloaded. Sorry about that. I had some sort of internet issues, but you can see here we're on level -1. And you can sort of make out individual trees and bushes. So if we go here, you can see that's the size of cars. So it's not a bad level. If you've lost your model, you could quite easily locate it, you know, within a few footsteps at this sort of scale. But you can go -2 if it worked. Right, so this is -2. This is the maximum zoom level. And you can see the cars are, well, twice the size of what they were on -1 by the looks of it. But me personally, I've gone for -1. I don't think it needs to be that zoomed in. And what is the distance? So that is 0.3 kilometers across, which gives us, so we're a quarter of a kilometer for the width. -1, we're at half a kilometer for a width. So I've gone for -1, 1, and 3 for my zoom levels. It should give us plenty of options. So one thing I was asked is, there's plenty of tutorials about this, but they've only been downloading small areas on the map. So I should have actually asked the guy, sorry, I can't remember who wrote it. I again should have looked it up. But they asked about downloading big areas. Now, what I will say is I have actually had this crash, and as you see, there's been a few issues on this computer with downloading the imagery. So I'm hoping that's just a temporary glitch. It's worked absolutely fine on my laptop, as I say, apart from one crash. And the thing with the crash was I was using it at the time to do other things. So I've left it since then overnight, and it's not had any issues at all. So just for test purposes, I downloaded an area that was about 84, 85 kilometers across and about 40 something kilometers high. It was basically 3,800-ish square kilometers of data at zoom level -1. So the time that took was, in about an hour, it would do, say, 7%. So you can see it took quite a long time, and it didn't crash during that period. So if you do want to go for a big area, so on that computer I was at zoom level 6, and of course it's based on monitor size, so I don't think it's going to be the same. So no, there's less on this screen than there was on that one. So it's somewhere. So if you imagine an area halfway between 6 and 7 on the other screen. So, but you can see that's quite a lot of area. Right, so just to give you an idea, that island is 36 kilometers across, or 22 miles. So that's this island here. So as you can imagine, that's a hell of a lot of data we're downloading. I would think if you left it alone, it would be absolutely fine. The more area, you know, the longer it's going to take. That's all. So right, so how do we download? So what I'm going to do is I'm going to zoom in to this area here, purely because this is where I'm actually going to get a fix, because I live in this area here. So what I'm going to do is you just, as I say, you just put the area that you want to capture on screen, right click and choose batch download. So it will tell you the size and the height, and then you set your zoom levels. So as I said, I was at 3, so I set those both to 3. You see that one's quite quick, and 1, and then this one will take a bit longer because obviously we're now at probably 4 times the reduction, so it will take longer to download. And then after this I will do -1, but obviously I won't record that. And finally I'll set this down to -1 and -1, and then we can download. So another thing that I've sort of requested is, rather than this minimum and maximum zoom levels, would it be nice if you know, like on a printer page, if you're printing something out, you can actually comma separate the pages you want. So I thought what would be nice, instead of a zoom minimum and maximum, is just to have a comma separated list of the zoom levels that you would like. So maybe -1, 1, 3, and then it would download those all at once. But I'm going to leave this to download, and I'll come back with you shortly. Okay, so our download has finished. So that's everything done from our mapping program. So we can just close this down and carry on with the rest of the installation. So what we need to do now is have a look in this zip file. So I'm just going to extract it, and then we can have a look inside. And what we want is this stuff in this Horus folder here. So you can see there's sources and there's SD, and we're going to just use SD. And all we're going to do is copy this onto our transmitter. So let me get our USB cable. And what we need to do when we plug it in, just go onto SD card, press enter. So now what will happen is I'll load up Windows Explorer, and what we have is our USB drive, which is our transmitter. So all we're going to do is copy in the scripts and widgets folders into the SD card root. So that will now just copy everything across. But what we also need to do is copy the map data. So for that, we need to go into our user drive on Windows. So yeah, if we just do copy that and paste that into here. And then what we want is this GMapCatcher, and then our 100 by 100, and now our satellite tiles. So in here, all we're going to do is select the zoom levels that we've chosen to download. So everything on here is basically what has been downloaded, but some of it's only going to be just from browsing the map, so it's going to be incomplete. So we have zoom level 3, zoom level -1, and zoom level 1. So once that finishes downloading the actual script to the SD card, which I believe there's a load of demo maps on there, so we'll get rid of that as well. But I'll show you how to do this next part. Okay, so that's finished downloading. So now what we're going to do is go into scripts, Yaapu, maps, and then sat tiles. Now you see there's already some demo content here. So what I'm going to do first is just delete these, because I don't know where it is. It's not going to be relevant to me whatsoever. So I'm just going to delete those. And now that they're deleted, we're just going to copy these new map tiles that we've just downloaded and created into the folder. can see it's 147 megabytes that we're mapped, and that's just for that small area. So obviously the bigger area, the more space you're going to need on your SD card. Now, I believe I've got 16 gig or 32 gig in there at the moment, so there's plenty of space. But yeah, just keep that in mind. Obviously the bigger area, the more space it's going to take up on your transmitter. Okay, so that's everything copied across. So now what we need to do is set up our transmitter to actually use the maps. Okay, so I've disconnected from the computer and I've just loaded up my standard R9 model, as I'm going to connect to my mini AR wing so we can get some GPS. But the first thing that we need to do is actually set up a way of zooming in and out on the map itself. So they recommend a 3-way switch, but on this transmitter that's just going to take up something that's useful. So I'm going to use this trim pot right here. So to do that, I'm just going to go into the flight modes, go along to trim 6 and disable it. So that is now no longer a trim. Next thing I'm going to do is set up a global variable. I'm going to call this map. I'm going to set the lowest value to -100, the highest value to 100, and I'm going to set the default value to -100. So now what we need to do is just create a couple of special functions. So the first one, so let's find the trims, and we want trim 6. So we'll do down first, then we're going to adjust global variable 2, so increment decrement, and we want to set that to -100. And then if we copy this, paste it, we can change this to 6 up, and then we just need to change this to +=100. So all that means is when we click it up, we're going to add 100, and when we click it down, we're going to -100. So we now have our 3 positions, -100, 0 and 100. And the final thing that we need to do is set that in a mixer. So we go back to the mixer, and because we're not sending this over RC, I'm actually going to put this on, I'm going to see if I can set it on channel 32. So this is going to be map. I've not actually checked to see on the script what we can go to. So map zoom. Right, so source, we're going to set this to max. And the weight, we're going to set to global variable 2. So at the moment we're on -100, click it up, we're at 0, click it up again, we're at 100. So that's everything done here. We can actually zoom in and out now. So what we need to do is set up our telemetry screens. So we'll long press on the telemetry button. And you can see I've already got a screen here for the iNav LUA, but I'm going to add another screen for the Horus map widget. So because this needs full screen, we need to get rid of the top bars and the side bars. And now we'll just click on Setup Widget, select that, and we're just going to scroll through until we find Yaapu. All right, so let's restart the transmitter, just in case there's something cached weird going on, and we'll try that again. Alright, so let's set up page 2, set up widget. Aha, there we go. Now we have Yaapu maps. So we just needed to restart. So I'm going to set that up on my screen number 1. So if we return back out of this now, if I press it once, we get Yaapu, press it again, we get iNav, and now we're back to this. So let's look at the setup while we're here. So we click on there. You can see the start zoom level, we want -1. We're on satellite. And the zoom channel, let's set this to 32 if we can. Oh, we can, brilliant. So that's now set up. I did notice that when the demo was on, you need to back out of it quite a few times. So what I'll do now is I'll just grab a battery and I'll plug in the AR wing. Right, so that's all plugged in. So we'll go to the model, we'll go backwards and just make sure we're getting telemetry. So we've got no GPS yet, but we're getting everything else. So I'd imagine we're just waiting on a fix. Right, so I've just had the beeps. So I know we have satellite fix. We've actually got 6 satellites. So what I'm going to do is just pop into Yaapu. And what you can see is we have a little arrow down here, which is the model. So this is pretty close. It's still obviously zooming in. We've got the GPS coordinates down here. And we have a zoom level here. So if I click this, you'll see there's no map data because we're at zoom level 0. I didn't download that. And then if I click again, we're at zoom level 1, which I did download the data for. So what you might notice is, so where's our little plane? Yeah, it's still on there. So the actual image for the plane isn't brilliant, but you'll notice that there's these areas here that are currently not filled in. Now you can add sensors on here, but we have to add them on the SD card, unfortunately. So there's nothing to click on here to do any settings. But what I'll do is I'll show you how to go through that soon. The other thing is, as I said, this at the moment, there's no map data because I haven't actually put it on there. But what I'm going to do is I'm going to install a version of Yaapu that I've actually put up as a pull request, so hopefully that will come up soon where we can define the map zoom levels. Okay, so before I progressed with the sensor information, I wanted to just go over the changes that I made because it does update the configuration file and we do have to edit that in the other thing. So what we'll do, we'll go into system and we click on the Yaapu Maps widget tool. You can see that there's now 3 zoom levels, not just the initial zoom level. So all you'd need to do is change this to match the zoom levels that you've downloaded in the map. That's it, done. And what we'll do, we'll just double check in the scripts folder, Yaapu mapconfig.lua, just to make sure that's the same, which it is. Sorry, and now what we're going to do is just restart the transmitter just to clear any caches or anything like that. That failsafe buzzer isn't too annoying, is it? Right, so now what we can do, if we page through into Yaapu Maps, you can see now we're out at zoom level 3, which is my furthest zoom level. Click 1, we're on zoom level 1, and now we're at zoom level -1. So it's quite hard to see, but it is up here. I'll see if I can zoom in on that. So -1, 1, and 3. So that's what's coming soon, hopefully, which I think is much more useful. But now we'll take a look here. Okay, so now we've got everything on our transmitter set up. We need to plug the transmitter back in to get our telemetry sensors on the borders of the LUA script. So what we're going to do is go to our our SD card, which is labeled USB drive when you plug it into Windows. We're going to go to our scripts folder, Yaapu, and CFG. Now what you'll see here is there are some examples set up for different types of configurations, but what we need to do is basically make a new file in here which is a similar name to this one. So what I'm going to do is click the rename option, which is F2 on Windows, and just copy that, and we're going to create a new text file and we're going to give it that name, but we need to add _sensors in here, and it needs to be a .lua file. So it will ask if you want to rename it or change the file type, when you just say yes. So now what we can do is edit this file here. So what we'll do is right click, and I use this really cool utility called Notepad++, which just opens just about any type of file. So let's take a look at their example file, because it'd be easier than just adding in a bunch of sensors. So it can be anything in OpenTX. So we've got the label, which is what I guess is displayed on screen, the OpenTX sensor name, the precision, all that sort of stuff. But what I'm going to do, there's our 10 sensors here. I'm just going to copy this whole script and paste it in here. If we want to change sensors at a later date, we can do that. The double minus is a comment in the Lua script, so anything where you see a double minus, what is after is not read by the actual Lua compiler, so don't worry about it. It's just these bits that are important. So let's just save that. That's on our transmitter, and then let's see what it's done. We need to restart it again just to clear the cache. I need this to zoom in. I need that to shut up. And now you can see we have our data. So there's some useful stuff there which we can obviously configure to our liking. There is other useful things on this as well. So we have our RSSI, which is from our default RSSI on the telemetry. We have the voltage left in the transmitter, and we have the clock, which is quite handy. I've not updated it yet for daylight savings, which I really should do. Okay, so I was just editing this video and I thought actually I can explain that a bit better. So we're going to take another look at the these settings along the bottom. As you might be able to see, they are slightly different to they were at the end of the last video, and that's because I've changed them to things that will make more sense to me, and I've just rearranged the order. You can see also that the units are different, so speed is in miles per hour now, altitude is in feet. It's just how I prefer mine set up. So you may see, well, you may have read earlier in the video that you can get all this information from your telemetry page. So what I thought I'd do is just show you where that was. So page back out. If we hold down the model key, if we long press, we go backwards to telemetry, which is of course where we've got our telemetry sensors. So what we can do actually in here is change the units. So let's find distance. You can see I've got my distance set at feet, but if I wanted it at meters, I'd just go to distance, and then in here I will change it to meters. Obviously you need to use a distance unit that's valid for that type of sensor. So you wouldn't set distance to degrees centigrade, for example. So, but what I was just showing you is this is where you can see what different units are available. So we're in distance now, we got feet, meters, so miles per hour is not acceptable, so it's just feet and meters. But if we go back out and look at maybe, so altitude is going to be the same. So ground speed, or GPS speed, sorry. We can have miles per hour, we can have kilometers per hour, we can have feet per second, we have meters per second, we can have knots. So those are the units that are suitable for that sensor. And it's just remembering what that is when you're setting up your sensor in the Lua script. Likewise, any of the sensors here you can put in the Lua script. So all you have to do is remember the sensor name. So for example, one of mine, you'll see I've got cell voltage, which is actually the A4 sensor. So if I exit out of this, we'll go back in here, you can see, where did I put it? AVG volt. So that's average cell voltage, which is the A4 sensor. So what I'll do now is we'll head over to the computer and I'll show you how I've changed this and set this all up. So first of all, again, just because it wasn't clear on that other video, plug the USB cable in. You want to set it to USB storage. And now we'll head over to the desktop. Okay, so I'm back at my SD card. You can see we have two files now because it's actually been run on the transmitter. We have the LUA file and the LUA-C file. Now, the LUA-C file, if I open it up, I'm assuming it will look pretty garbled, yeah. So this is the LUA file that we're working from, and this is the LUA-C file. So LUA-C is basically just a compiled LUA script. So it's faster for running. But what we do need to do is, because we're going to change the LUA file, we need to delete the LUA-C file. Otherwise, it will just use the compiled version. So if you're going to make changes, just make sure you delete that LUA-C file. And that's also why we need to restart the transmitter when we make changes, because it's actually caching this file, so it's running it from memory. So when we restart the transmitter, it will create the compiled LUA script and it will run that. So if we open this up, what we can do is have a look at what I've changed. So first of all, I got rid of those unnecessary comments, and I've changed the ordering of some of the sensors. Now, what I've brought up is this iNav GitHub page, which is pretty useful if you're using smart port sensors. So it actually goes over what they are, and basically, so you have the sensor name and then it's a description of what it actually does. So if you remember a second ago, I was talking about A4. So you can see A4 average cell value. So what you'll do is, as I sort of guessed at in the original part of the video, the label is just the text label. It's what appears on the display for that sensor. So what I'm going to do is go down to the A4 sensor. I could have got rid of that. So you may notice that on some of mine, the numbers here aren't in numerical order. It doesn't really matter. It's just inserting it into this programming thing called an array. The important thing is that the number resolves to the space on the transmitter that you want that sensor. So I've just rearranged stuff. So you can see here 10 is after 7. It doesn't actually mess anything up with the programming. So right at the very bottom, I've actually got sensor 8, which, if you remember, is the second one down on that right hand panel. So you have 1 through to 6 along the bottom, and then 7, 8, 9 and 10 down the side. So number 7 is the VFAS, which, if we look on here, is the actual battery value. So that's the current voltage of the pack. And then the next one down is A4, which is here, is the average cell value. So I've named this one average, AVG. You could call it cell, whatever you want. You can look at other things. So precision is how many decimal places there are. You can have 0, 1 or 2. V is the unit of measurement. So that's what I was showing you on the transmitter on the telemetry screen. So for this we have volts, but if I go back up to V speed, for example, it's a speed. So in there we currently have meters per second. We could have feet per second. We could have knots, miles per hour, kilometers per hour. So any of those 5 units of measurement will be fine for a speed. So that's what I'm saying. Just check on your transmitter, see what you got on there, and whatever you want it to be. So for me, feet per second might be better because I'm actually measuring my altitude in feet. You have different font sizes, and then you can set warning levels. So I've set the cell voltage up to have a warning level if it's 3.65 volts, and then it's critical at 3.3 volts. So if you didn't want a warning, you could just set it to nil like the rest of these. I hope that explains it a bit better, but what we'll do is we'll save this and see what the changes come up like. So like always, we've made a change, so let's restart the transmitter. Oh, I was plugged in still. Alright, so if we now go into our maps telemetry screen, you'll see that the vertical speed is now in feet per second. So if you wanted to look at that configuration file, this is sensor 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what I'll do is maybe I'll put my sensor settings in the video description. It'll make things easier for you. But I hope that that clears things up a bit better than how I described them previously. But anyway, thank you guys for watching. If you found this video useful, please give it a thumbs up. If it was crap, give it a thumbs down. But if you do, please leave a comment to say why you left the thumbs down so I can try and improve these videos. If you haven't already, please consider subscribing and clicking the bell icon. It will help get this video out to more people so they can learn how to install this Lua scripts, or how to install any Lua scripts in fact, but this one in particular with its settings, yeah, people may find it useful. So thank you very much, guys. I hope you all stay safe in these times. If you do get out to fly, have a lot of fun, fly your models like you stole them, and I'll see you on the next one.